Lesson 4-9 Negative Exponents, and in this lesson you learn to use negative exponents in expressions and equations. And it's important because negative exponents are often used in science to talk about small numbers like the size of a red blood cell. Okay, let's take a look at this activity and see how this works. You can often discover important concepts by looking for a pattern. Copy the table at the right, use a calculator, complete the second column. Letter A, describe how successive expressions differ. Letter B, describe how succession values differ. And letter C, if the pattern continues, what is the next expression? Letter D, if the pattern continues, what is the next value? And letter E, use a calculator to verify that the expression you wrote for part C is equal to the value you wrote for part D. Okay? Let's fill this up using a calculator. 2 to the 4th power is the same as 16. 2 to the 3rd power is 8. 2 to the 2nd power is 4. 2 to the 1st power is 1. And with a calculator, anything raised to the 0 power will also be 1. Okay, so 2 to the 1st power is 2, I'm sorry. Okay, so let's do letter A. Describe how successive expressions differ. Okay. The exponents obviously differ by 1. 6, 5, 4, 3, 2, 1, 0. Okay, describe how successive values differ. Okay, each value is half of the previous value. That's letter B. Each is half the previous value. So 64, 32, 16, 8, 4, 2, and 1. Okay, if the pattern continues, what is the next expression? So if we follow this, 6, 5, 4, 3, 2, 1, 0, the next expression would be 2 to the negative 1. If the pattern continues, what will be the next value? So if this is half every time, so the next value will be 1/2, right? And use a calculator to verify the expression you wrote for part C is equal to the value you wrote for part D. So meaning you get 2 to the negative 1, punch it in your calculator, you'll find out that the value will be equal to 0.5 or 1/2. Okay? So what does that tell us? Tell us something about a negative exponent, and let's learn the concept. Extending the pattern above suggests that 2 to the negative 1 is equal to 1/2. You can use the quotient of powers rule and the definition of a power to simplify the expression x cubed over x to the 6th power and write the general rule about negative powers. So let's use the quotient of power rule. Quotient of powers rule, x to the 3rd over x to the 6th is the same as x to the 3 minus 6. If you recall, the quotient of power rules indicate that a to the m over a to the n is equal to a to the m minus n. And that's why we did x to the 3 minus 6. And 3 minus 6 we know is x to the negative 3. And let's do the definition of powers by simply expanding it. This is x to the cube, 3x's, 6x's, as used as a power 6 times. And then we cancel out our common factors, x and x with a 1 there, okay, and you end up with 1 times 1 times 1, obviously it's going to be 1 over x cubed, okay, so that is 1 over x cubed. So if you notice, okay, x to the negative 3 should be equal to x 1 over x cubed. Since x over 3 over since x cubed over x to the 6 cannot have two different values, you can conclude that x to the negative 3 is equal to 1 over x cubed. This and other examples suggest the following definition. So after we use method 1 and method 2, we can now create our negative exponents, which means for any non-zero number a and any integer n, a to the negative n is equal to 1 over a to the nth power. Okay, And let's see how this works in our example. Write each expression using positive exponents. 10 to the negative fifth power. Copy the problem down. 10 to the negative fifth power. And using our definition of negative exponents, 10 to the fifth power is the same as 1 over 10 to the fifth power. Let's take a look at example B. AB to the negative 3. Okay. A is not raised to the negative 3, so wait, let's copy the problem down first. A is not raised to the negative 3, so we can please simply keep A, but B is raised to the negative 3, so this becomes 1 over B cubed. So it's A times B to the negative 3, so this becomes 1 over B cubed, according to the definition of negative powers. And you end up with, since if you want to write down 1 over here, so if you multiply those two, you end up with A over B cubed. Okay, let's take a look at example 2. Negative exponents are often used in science when dealing with very small numbers. Red blood cells are circular shaped cells that carry oxygen through your bloodstream. A red blood cell is about 7.75 times 10 to the negative 7 meters across. Write the width of a red blood cell using positive exponents. And letter B, write the width of a red blood cell as a decimal. Okay, so let's do letter A first. 7.75 times 10 to the negative 7 is equal to 7.75 times 10, 1 over 10 to the 7th, according to the definition of negative exponents. So this becomes 7.75 over 10 to the 7th meters, and that is using positive exponents. In letter B, we simply use a calculator to solve this, okay, as a decimal. 7.75 divided by 10, and you punch that y to the x value, y to the x button by 7, end up with 0.000000775. Okay? Example number 3. Write each fraction. Before we do example number 3, you can use prime factorization of a number to write a fraction, an expression, as an expression with negative exponents. So we want to write a fraction as an expression using negative exponents, 1 over 8. Okay? Copy the problem. We know that 1 over 8 is the same as 1 over 2 cubed. Okay? And according to the definition of exponents, okay, which states that a to the m, negative m, is equal to 1 over a to the m power. So in this case, 1 over 2 over 3 is your 1 over a to the m, and we want to convert it to this form. So 1 over 8 is the same as 1 over 2 to the negative 3, according to the definition of negative exponents. We'll do the same with letter B. Copy the problem first. Okay, and we know for a fact that x over y squared is the same as x times 1 over y squared. And again, we can use 1 over y squared using the definition of negative exponents to become x times y to the negative 2, or xy to the negative 2. Okay? And finally, let's do number 4. Our connection to algebra, expressions involving variables can also contain negative exponents. Let's evaluate the expression 4x to the negative 3 if x equals 3. Again, the meaning of the word evaluate means to find the value of the expression, and in order to do that, we need to substitute and we need to simplify. So first things first, let's copy the problem. Then substitute the value of x. Okay, you now have 4 times 3 raised to the negative 3. Okay, when you do that using the definition of exponents, you now have 4 times 1 over 3 cubed. Okay, 3 cubed is the same as 4 times 1 over 27. And if you multiply those two fractions, you end up with 4 over 27. Okay, and that's how you use your negative exponents in these types of algebraic fractions and expressions. And that's the end of the lesson. Thank you for watching.